This is the brand new Anker F3000 and it is packed with features, but there's one specific feature I'm really excited about. Now if we look closer at the front of the power station, you wouldn't really notice until you remove this flap right here. They've added a 12 volt 30 amp DC output. Me and my viewers have been waiting years for Anker to add a high DC output to their power station, so it's exciting to have a power station that finally has that feature. Now this power station sits between the previous F2000 and the newly released F3800 Plus, so let's take a second to go through some of the specifications. Starting with the battery, it's a 3072 watt-hour lithium iron phosphate battery. It's rated for 4,000 cycles till 80% of the original capacity. The F3000 has a 3600 watt pure sine wave inverter. I love that they've included the RV outlet right here. And the best thing is the idle power consumption on this inverter is extremely low. It's around 24 to 25 watts. Now another new feature with the F3000 is the ability to fast charge with their new 30 amp charging cable. This allows for up to 3600 watts charging input. So while in UPS mode or pass-through charging, you can get the full 3600 watts. Previous models only allowed 1440 watts, so that's quite the upgrade. Now I've just flipped the power station around because on the back you have access to the dual solar charging ports. Now from both these ports combined, you can get an impressive 2400 watts input, 1600 watts from this high PV port and 800 watts from this low PV port. And of course, I'll be testing these later in the video. Now what about charging your mobile devices? On the front you have two 100 watt USB-C power delivery ports, and then below that you have two USB-A quick charge ports. Now if you need to power basic 12 volt loads, you do have a 12 volt cigarette port here in addition to the 12 volt 30 amp outlet we already discussed. Now you also have the ability to connect two F3000s together using Anker's dual voltage hub to get 240 volt split phase output up to 7200 watts. Now the power station does support expansion batteries. You can connect 3 expansion batteries per main unit, and if you use the dual voltage hub, you can connect 2 of them together. So for 1 stack, it's 12 kilowatt hours of capacity, and for 2 stacks, it's over 24 kilowatt hours of capacity. Now, after covering all the features and specifications for the F3000, you can see why I'm excited about this power station. Now, I'm sure you guys are curious about the price. This is on a massive sale right now as this video goes live. This is priced at $15.99 or only 52 cents per watt hour, which is one of the lowest prices that I've seen on one of the larger Anker power stations. Now throughout the remainder of the video, I'm going to do extensive testing on the power station and provide you guys with a ton of performance data so you'll know if you want to purchase this power station or not. Now all of this testing takes weeks of my time, so if you do find this information helpful and you end up purchasing the power station, please support the channel by using the affiliate links down in the video description. Well, let's go ahead and jump into the testing. First, I wanted to see if the power station could run the maximum advertised load for 15 minutes, which is 3600 watts. During the test, my oscilloscope was showing an excellent sine wave output, and it measured 121 volts at 60 hertz. This is the same high quality power you'd expect to see from your utility company. After 10 minutes of running the maximum load, the cooling fans were at full speed. I measured 53 decibels with my sound meter from 3 feet away. I then used my thermal camera to confirm the power station temperatures during the test. I saw a peak of 119 degrees Fahrenheit near the exhaust fan ports, indicating no signs of overheating. The F3000 was able to run the full rated load for 15 minutes without shutting down. Now what about the maximum wattage the inverter allows you to pull before it overloads? I turned up the load from our previous test till it got a little over 5300 watts and the inverter shut off. So you do have quite a bit of power available above 3600 watts before the inverter shuts down. Now for the next test on the F3000 inverter, I'm out here in my shed where we can test the inductive or surge capacity of the inverter. I have my inrush clamp meter on the inverter here. We're going to see if it can power up each one of these loads without being overloaded. Now for our first test, I've connected up this 10 amp air compressor. Now what's interesting is because this has a motor, usually it'll pull double or a little bit more than that as it starts up. So instead of seeing 10 amps, we should see over 20. Watch this screen right here. Let's go ahead and turn it on. So the inverter powered this up without an issue at all, and it pulled a total of 22.75 amps on startup. Next, we'll be stepping it up to a slightly larger motor at 12 amps for this vacuum. Let's go ahead and turn it on. So the inverter powered up the vacuum without an issue, pulled a total of 36.61 amps. Now the next appliance that we'll be powering up is this large 15 amp table saw. Most small power stations can't handle this load. I've connected in the table saw. Let's see if it turns on. So it did power up the table saw. We got a total of 42.63 amps. Now just as one final test, I want to see if it can power up the vacuum and the table saw at the same time. Let's give it a go. So we did see a little bit more amperage at 46.88 amps. That's probably the peak the inverter is going to allow before we get a bit of voltage drop. But hey, it powered up both the table saw and the vacuum at the same time, so the inverter can definitely handle a bit of surge. Next, let's go ahead and test the UPS cutover on the F3000. It's advertised to be 20 milliseconds. Now for this test, I have a desktop workstation, monitor, and studio lights all connected to the AC inverter. I'm also running a stress test on the PC to simulate a load. Next, we're going to use my oscilloscope to measure the cutover. So I've used the cursors to line up where the power cut out and where it resumed. And if we measure the distance between these 2 points, it's only 9.8 milliseconds, so much faster than advertised. Now great news, the computer is running after that first test, but let's do a couple more. So second UPS test in 3, 2, 1. So just a quick flicker of the lights, but you can see the computer is still running. Third and final UPS test in 3, 2, 1. Okay, everything's still running. UPS works great on the F3000. So on my next test on the AC inverter, I want to make sure that these outlets here are wired properly. I also want to test to see if they have an open or floating ground or a bonded ground. So with the AC inverter turned on, you can see that these outlets here have a floating ground. And when we connect into the 30 amp RV outlet, we also get a floating ground. Now what happens when you connect the AC charging cable? Well, the power station picks up ground from the charging source and it becomes grounded. Now we also get the same results when connecting to the 30 amp RV outlet. Now the F3000 inverter has one other cool feature. If you double tap the power button for the inverter, it'll turn on the inverter, but it'll be a bonded connection, meaning the neutral and ground are tied together. Now this is called EV mode. It's for charging electric vehicles. Just be aware, whenever you're in this mode, you cannot AC charge the power station. You can only charge with DC inputs, so batteries or solar panels through the DC input ports, and that's because they don't want you to get a grounding loop. How much usable capacity should you expect when running loads off the inverter? I discharged the power station with a resistive load until the battery died and measured 2,760 watt hours of usable capacity. This result is 89.8% of the advertised capacity, which is a bit higher than our goal of 85%. I also completed an additional capacity test with the F3000 expansion battery. When the power station shut off, I measured 5,530 watt hours, or about 90% of the rated capacity, so you do get a good amount of extra capacity using their expansion batteries. Now how much power is used as the AC inverter is turned on for a long period of time? Starting with the power station fully charged, and leaving the inverter on for 12 hours, the state of charge had dropped down to only 92%, meaning the inverter used 8% of the battery over a 12-hour period, or only 0.66% per hour. That's really efficient. Next, does the inverter produce any interference? I measured over 2,000 millivolts of EMI using my dirty electricity meter, indicating that the inverter generates an above average level of electromagnetic interference. But is that level actually audible? Connecting my guitar amp into the inverter, I didn't notice any audible noise. In my final test, I wanted to demonstrate how long the F3000 could run a portion of my house during an extended power outage. The power station was connected up to my transfer switch with all 10 circuits enabled. Up on the screen, you'll see a breakdown of what's powered by that transfer switch. The power station ran for a total of 13.5 hours before it finally shut off. During this test, I saw an average of 400 to 600 watts being used, with the occasional jump in higher wattage as multiple appliances were turned on at the same time. Now that's a decent runtime, and you can easily extend that by adding expansion batteries or charging with solar panels. Wow guys, usually after all those AC inverter tests, I have multiple things that I get nitpicky about, but the performance on this inverter was just really good. It had 120 volts output, it was a great sine wave, it surged really well with our power tools. The idle power consumption was great, only at 0.66% per hour. That's way better than previous Anker power stations I've tested. The UPS cutover was under 10 milliseconds. During our capacity test, we got 89% of the rated capacity, which is above average. So yeah, not many things to really complain about. If I got really nitpicky, I'd say the fans are just a teeny bit loud on this, but we've tested power stations recently that were over 60 decibels and the fans were just screaming. So compared to that, these fans aren't loud at all. So very good performance on the AC inverter. In the next section of the video, I'm excited to test the DC output and USB ports on the F3000. So let's get started. Now, if we take a closer look on the left-hand side, you have your 12-volt output. This is a first for Anker. We have a 30-amp Anderson connection. I'm really excited to test that out. And right here, we have a 12-volt cigarette port. You turn these on by pushing this button. Now, on the right-hand side, you have your USB ports. You have two quick charge USB-A ports, and then you have two 100-watt power delivery USB-C ports. Now, first, I want to test the 12-volt output, starting with the cigarette port. So I've connected it up to my electronic load. We are seeing a regulated 13.37 volts. Now typically these are rated for 10 amps. So let's just try turning it on at 10 amps. Okay, so it's gonna be a little hard to see on the screen there, but we are seeing 132 watts output. Let's try 11 amps. Okay, so you'll notice as we get a little bit higher in the amperage, the voltage drops down. Now this is typical if we are near the point that it cuts out. So let's try 12 amps and see if it can handle it. Okay, so at 12 amps it shuts off. So it looks like the maximum power that you'll be able to get through the 12-volt socket is right around 133 watts. Now what about the 30 amp output? We have the Anderson port here, which is rated for 30 amps. I have my electronic load set for 30 amps. Let's go ahead and turn that on. Okay, so right away here on the screen, you can see 399 watts. So yes, it is able to handle 30 amps. Now I'm gonna run this for a couple minutes just to make sure it doesn't shut down. I'll check back here in a second. So it's been about 10 minutes so far and the 30 amp load is still running, so that's a good sign. And take a look at this. We've only dropped down 3% state of charge, pulling 400 watts. So it just shows you how big the battery is. Let's go ahead and try turning it up to 31 amps just to see what happens. Okay, so now we're seeing 413 watts on the screen. Let's try 32 amps. Okay. So now we're seeing 427 watts on the screen. 32 amps is just fine. Will it go up to 33 amps? Okay, so 33 amps or about 440 watts. That is a crazy amount of power. Let's just see if it'll go up to 34. I'm guessing that it's gonna shut off. Okay, so right at 34 amps, it shut off. So you can get about 440 watts from that 12-volt output. Now what about the USB ports? I wanna test each one of these USB ports to make sure they put out the advertised power. Starting with the top one, it is a 100-watt power delivery 3.0. We are getting 20 volts at 5 amps, and we are charging this power bank at 96 watts. Now I've just connected into the second 100-watt port, and we are getting the same results. Power delivery 3.0, 100 watts. Now moving on to the two USB-A ports, each one of these are rated for 12 watts, and we are getting dedicated charging protocol, 1.5 amps. We are seeing a little bit higher amperage and almost 10 watts into the power bank. And finally, the last USB port, we are seeing the same results, dedicated charging protocol, and about 10 watts into the power bank. Now I also wanted to make sure that you could use the USB ports and the DC output at the same time. So in order to test that out, I'm charging two different power banks at 100 watts. I'm charging both of my cell phones off the USB-A ports, and then I have 30 amps going out through my electronic load. Now if you look closer at the screen here, we are pulling 570 watts while charging these devices and powering the DC loads. So you got a lot of power available with the F3000. Now, how much usable capacity can we expect from the DC output? Using my electronic load to discharge the power station, I measured a total of 2,796 watt hours as it turned off. These results were 91% of the advertised capacity, above my goal of 85%. Now, how much idle background power is used if you leave the DC output turned on? I started with the power station fully charged, and checking in 12 hours later, it was still at 100% state of charge, so the DC output uses very little power when enabled. So after all the DC testing, we see more great performance from this power station. I was impressed that we got 91% of the advertised capacity on our discharge test. Usually you don't get that good of capacity through the DC output. It's super efficient. And I love that it has the full 30 amp output, so you can get easily over 400 watts with that output. Now, the one criticism that I'd have about the DC output and the USB ports is the fact that they put two 100 watt USB-C power delivery ports when the standard's kind of 140 watts right now. I would have liked to see two of those higher powered USB-C ports, but it's definitely not a deal breaker. Now, Anker, if you're listening here, if you're planning to launch a 2000 watt hour device that's similar to this one, please make sure that you put the 30 amp output on the front. There's just not that many options that are currently available with the 30 amp output, and we'd love to see you guys launch one that's similar to this. So in the next portion of the video, we're going to go through all the charging options on the Anker F3000 and do a bunch of testing. Now these are the two cables that are included with the power station. This is your standard AC charging cable. This is rated for 15 amps and 120 volts input. And you'll notice that it's using a new style of connector. This is a twist lock connection. And I've also noticed, it's kind of hard to see, but there are communication pins on the inside. And I'm guessing that's for the power station to determine what size of cable you're using, because like I said, this is the 15 amp charging cable, but they do offer an additional accessory you can purchase, which is a 30 amp charging cable for faster charging. Now for solar input, this is the high PV input cable. This is basically the same adapter that we see with the new F3800 Plus, that same proprietary connection here, but it also comes with MC4 connections to plug in your solar panels. Now here's a closer look at that 30 amp AC charging cable. You can see it uses an RV style connector on this end, and then the other end is basically the same. It's good to see that they're offering a faster charging option, and I'm excited to test that cable out. Now under this flap on the side of the power station is the AC charging port where those cables connect. And I'll just demo that it is that twist lock, so you can see it's super secure. And then to get it out, you just push this down, give it a little wiggle, and it comes out. Now if we flip the power station around to the back, we actually have the solar inputs. There are two charge controllers on this power station. Right here is your high PV input. This is rated for 1600 watts. The voltage range is 11 all the way up to 165 volts and up to 17 amps. Now this is your low PV input. It's rated for 800 watts. It's an XT60 port. It's rated for 11 all the way up to 60 volts with a limit of 17 amps. So both of these combined, you can get 2400 watts into the power station. So let's go ahead and jump into some actual testing with the solar input ports. I'm connected to the low PV port with my adjustable power supply. To simulate a 12 volt battery, I have this set to 13.5 volts, and the power supply is also set to 20 amps output, but the power station is limiting that to about 7.7 amps. So if you look at the screen here, we are charging right around 100 watts input. So you'd expect around 30 hours of charge time, probably a little bit more if the power station was completely empty and you were charging off 12 volts. Now what about connecting 12 volt solar panels in parallel? I have the adjustable power supply set to 18.5 volts, which is common for 12 volt solar panels. The power station is limiting the input to 8.1 amps. So if you had a bunch of solar panels connected in parallel, you'd only see about 150 watts input, and that's because it's still limiting the amperage here. We're going to need a higher voltage for it to jump up to the higher amperage input limit. Now I've raised up the voltage on my adjustable power supply to simulate a 24 volt battery, so I have it set to 26.5 volts. We are still getting the same amperage, 8.1 amps. So from charging off a 24 volt battery, you can expect right around 200 watts. So I'm thinking we're going to have to get over 30 volts in order for us to get the full 17 amps input. Now I've slowly been raising up the voltage of my adjustable power supply until the amperage kicked up. So right around 29.5 volts, we jumped up to nearly 17 amps input. And remember, 17 amps is the limit. So it looks like you're going to need at least 29.5 volts to get that full amperage input limit. Now remember, for this test, we are connected to the low PV input, which is good for up to 800 watts. We can get 60 volts input and 17 amps. How much power would you expect if we connected up 400 watt residential panels together in parallel? Remember, you have to connect them in parallel so you don't go over the 60 volts. Well, most of those panels are going to put out 33.5 volts. We are getting the full 17 amps input. So 560 watts is what you should expect if you had 400 watt panels wired together in parallel on the low PV port. Now that's because we have a pretty low amperage input limit at only 17 amps. If you remember the original F3800, you get up to 27 amps after the firmware update. So you see a reduction at about 10 amps. So 560 watts, plus or minus maybe 100 watts, depending on your solar panel voltage. Now for my last test on the low PV port, I'm curious how much power we'd expect if we connected up a 48 volt lithium iron phosphate battery. So I've set the voltage to 55 volts. We are getting a little over 15 amps input, and we are getting about 835 watts. So actually a little bit over the 800 watt limit. So if you connected up a 48 volt battery, that's the power you'd expect to see on the low PV port. So I've disconnected from the low PV port and I've connected my adjustable power supply up to the high PV port. Now they're essentially the same up until this point because they both allow up to 17 amps input. However, the low PV port is limited to 800 watts and the high PV port goes up in voltage up to 165 volts and allows up to 1600 watts. So with the same settings here on my adjustable power supply, we are getting a little boost in power. We are getting up to 926 watts, so about 100 watts more if you were to connect up a 48 volt battery to the high PV port. Now I have one final test that I want to do with this adjustable power supply. Unfortunately, this is limited to 1200 watts, so we can't hit the full 1600 watt input limit on the power station. But to max out my adjustable power supply, I have it set to 69.5 volts, and we are getting a little bit over 17 amps, so 1173 watts. So that is basically maxed out with this adjustable power supply. So in order to test the full input, I'll be testing with solar panels here in a couple minutes. So now I want to swap gears and we are going to be testing AC charging on the F3000. I have the Smart App here. So you can see we are getting 1789 watts input. That's because it's set to the fast charging speed within the Smart App. Now you can come in here and you can adjust the AC charging power. So with the current charging cable, which is the 15 amp charging cable, it's set to 1800 watts. Well, let's just try 1200 watts, see if that adjusts, drops down. Usually it takes a little bit of time, but right there on the screen, we are getting right around 1200 watts input. Let's just drop this down all the way to 200. And we'll see if it also adjusts. Okay, so 200 watts. So yes, the F3000 does have full adjustable charging. I love when a power station lets you adjust the charging in these small increments. Last setting, I'm just going to set it to 1000. And there we go. We have 1000 watts charging there. Now, right below that, you can see we have a 30 amp charging setting with a 30 amp cable, and we also have an EV charger setting. So let's connect up the 30 amp charging cable and see if we can get the full 3600 watts charging. So I've just connected the 30 amp charging cable up and we are charging at almost 3600 watts. Now it is adjustable in the Smart App, so I'm going to come in here and I am just going to drop it down to 3000 watts just to make sure we can adjust the charging speed. Yep, drop down to 3000. Let's go all the way down to like maybe 1500. I think this is really cool to have the 30 amp charging cable, but to have full adjustability in the charging speed as long as you have the Smart App. Yep, charging at 1500 watts there. How low does this go? Wow, all the way down to 200 watts. That's awesome. Yep, set that in the Smart App and it's dropping down. So full adjustability. I love that this has a 30 amp charging cable too. Now I also wanted to test dual charging on the Anker F3000. So can it charge with DC input and AC input at the same time? So I have my adjustable power supply connected to the high PV port. I'm also using the 30 amp charging cable connected up. And if we look in the Smart App, we are charging at around 1150 watts from the DC input and 1800 watts from the 30 amp charging cable. Now that's because I have it set to 1800 watts. Let's turn that up. I'm going to turn the AC charging speed up to 2600 watts. And we'll see if one has a priority over the other. It's going up to 3750 watts. Wow. In the Smart App, we're seeing a breakdown of 2600 watts AC input and 1150 watts DC input. Let's try just maxing it out one last time. Let's see if it'll go all the way up to 3600 watts at the same time. That would be crazy charging speed. Okay. we are seeing a peak input of about 3,829 watts. So that looks to be the full charging speed with dual charging connected at the same time. Now for my last test before we take this outside and test with solar panels, I want to make sure that it supports full pass-through charging, meaning that you can charge with AC input and still get full capability of the AC inverter, the DC output, and the USB ports. Now as we look closer at the screen here, we can get a breakdown of what's actually going on. So we do have almost 500 watts going out. We have almost 1,800 watts going in. All the outputs are enabled. So yes, this does support full pass-through charging. So let's go ahead and move forward with solar testing on the Anker F3000. Now you remember there are two charge controllers. You have a high voltage input, which is good for 165 volts. And we're going to be connecting up this 1,600 watt array to that. There are four 400 watt panels wired together in series. Now for the lower voltage input, it has a 60 volt limit. It's designed for portable panels. So I have these two 450 watt panels that I'm going to wire together in parallel and connect into the lower voltage input. Now, as for the solar conditions today, it is a pretty clear day. We just have a little bit of haze. It's pretty warm. It's around 85 to 90 degrees, and we are testing at midday. So we'll see how much power input we can get with these solar panels. Now I'm here in my basement where the solar wires come in. They come in from outside through this conduit into this breaker box where each array has its own DC breaker. Now I have two of these shut off because I recommend turning them off before connecting them to the power station so you don't get a spark. But if you look on the back here, I have the XT60 to the low PV input and the proprietary connection to the high PV input. So let's go ahead and turn these on and see how fast it can charge. Now I've just turned the breaker on for the high voltage input and we are getting a little bit over 1,250 watts. Now this is typical for this time of year from that solar array just because the panels are pretty warm and they're not angled perfectly at the sun, but almost 1,300 watts is pretty decent from that 1,600 watt array. Let's go ahead and turn on the breaker for the low voltage input and see if it'll allow dual charging with both those solar inputs at the same time. Now I've just enabled the breaker on the low voltage input and you can see that it is allowing both to charge at the same time. We are getting 1,900 watts input, so about 650 watts from the portable panels. So it's great to see both solar charge controllers work at the same time, and we are charging at almost 2,000 watts here, so this is going to charge the power station super fast. Now since the Anker F3000 has two DC charging ports, I'm curious what's going to happen if we have both charging ports connected up to the same source. Now right here I have a bunch of different 48 volt batteries and they are all tied together in parallel using these bus bars. And then I have two DC breakers where the wires are coming off and going into the DC charging ports. So essentially I can use these 48 volt batteries as a DIY expansion battery, but will it charge from both at the same time? So I've turned on the DC breaker for the low PV input and we're charging around 837 watts. So I'm going to go ahead and turn on the breaker for the high PV input. So what we're looking for is both to charge at the same time. So are we going to see more than 837 watts? Okay, it's jumping up. Awesome. Take a look at that, guys. It allows you to charge from the same source on both those inputs. So connecting up your own 48 volt battery as an expansion battery on both ports, you're going to charge at over 1,700 watts. That is awesome. I also tested having solar panels connected overnight on the F3000. In the morning, once the sun started coming up, the power station started charging, and I didn't notice any issues during this test, so it's okay to have solar panels connected all the time. I also tested having the power station completely turned off and then plugging in solar input. The power station turned on and started charging, so solar panels do wake up the power station if it's died or if it's been turned off. I also wanted to test the AC charging efficiency, or how much energy it takes to fully charge the battery. Starting from empty, I tracked the usage with an inline watt meter, and I measured 3,630 watt hours to charge the 3,072 watt hour battery, which means the charger is about 84.6% efficient. Holy Toledo, that was a ton of charging tests. Now as for the actual performance, 30 amp input cable is awesome, 3,600 watts input and pass-through charging. That is sweet over the previous models of Anker power stations. The DC input is very good as well with 2,400 watts combined from both of those solar charge controllers. I love that you have the high PV input and the low PV input. And the fact that you can connect up a 48 volt battery to both those ports at the same time and charge at 1,700 watts is awesome. Now you do have the ability to charge with AC input and DC input at the same time as well, and you have full adjustability using the Smart App to adjust the AC charging speeds. Now before we jump into grading this power station, I will do a brief demo of the Smart App for this power station, but before that, I want to talk a little bit about the weight and warranty. Now this power station comes in at 91 pounds. It is fairly heavy, it's a little bit bulky, but that is because it's well built. You have this metal handle here, you have the wheels that are built in, so it is pretty hefty. So you're gonna want two people to kind of carry it up and down the stairs, but moving it around with the wheels and handle is pretty easy on a hard surface. Now, as for the warranty, Anker is offering a 5-year warranty on this, standard with their other products. And I've heard really good things about Anker customer support. So if you do have experience with Anker customer support, please leave a comment down below and give me your guys' feedback, because I always like to hear how well it works. If you have issues or if it's just a great experience with Anker customer support. So let's take a second to go through the Smart App for the Anker F3000. So at the top, you're going to see the power station with the state of charge and then the internal temperature. You can see it's at 73 degrees. Now, if we scroll down a little bit, you get a breakdown of the DC input and the AC input. So if you were charging here, you'd see what wattage was there. And then below that, you have all the outputs. So you get a breakdown of each USB port. Then you have the car charging output and the AC output, so the DC and AC output. And you can actually turn these both on remotely via the Smart App. And then you also have this timer next to it where you can set when you want that to shut off. It's like a built-in timer that you can do if you'd like. Now, by default, you don't have to worry about the timer. You can just set up the eco mode settings, and I'll show you that later here. Let's go ahead and turn both of those off. Now, there's also a light bar across the top of the power station. You can turn that on low, medium, or you can turn it on high. I like that this is an ambient light, so I'm just going to turn that off. You also have the ability to turn off the screen. So if you're trying to sleep and you don't want to have any light at all, you can turn that off. So I'm going to go ahead and turn that back on. Now, if we go to the top, there's a settings cog, so we'll click on that. Now, the first option is the adjustable charging. So you can set the charging speed for the default charging cable, which is the 1800 watt cable. Below that, you have the 30 amp charging cable, and then below that, you have the EV charging cable. Each one of these has the ability to adjust them. For example, you just click on them and you can adjust what type of wattage you want to set. I'm going to go back to the previous setting. Now, below this are the eco mode settings, so the saving modes. So the car charging saving mode, anything below 3 watts for 5 hours is going to shut off if you have that enabled. And then for the AC mode, basically anything below 20 watts for 15 minutes, it's going to shut off the AC output. So I think that's a little bit extreme. I like how efficient the AC inverter is, so I'm not going to worry about turning either of those on. You have the ability to turn off the device if it's not being used. That's the device timeout. The screen brightness. I suggest having this set to high so you can see it throughout different light settings, but you can set that between low, medium, and high. And then you have the screen timeout. So when I'm recording these videos, I usually have it set to 30 minutes just so it doesn't turn off on me, but you can turn it all the way down to 20 seconds, which is nice. Now you can adjust the device name, the Wi-Fi settings. You can change the temperature between Fahrenheit and Celsius. You can see the serial number, and then also you can update the firmware. So you can see I'm running the latest firmware on the device. Now up on the screen, you're going to see the results for my power station grading system and the Anker F3000. Now, anybody that's watched the video, this will not be a surprise. The power station got a perfect score, 10 out of 10 points, and it performed very well in all of these requirements. So this model definitely makes the recommendation list for power stations that I've tested. Well, there you have it, the full testing and review video for the brand new Anker F3000. Now, throughout all the tests today, this has been a very solid performer. Just a few little nitpicky things that I'd like to see improved on, but overall, I can't complain about the performance. Now, if you guys are interested in this power station after seeing today's video, I'll make sure to include a link down in the video description. It will be an affiliate link, so by purchasing the power station through that, you are supporting the channel and supporting all the work that I do for these videos. Now, lastly, what I want you guys to do is leave feedback about this power station. Let me know what you guys think about it. Let Anker know what you think about it, because that feedback is very important so they can always make continued changes on their power stations to make them better. Now, on the left-hand side of the screen, I'm going to recommend a couple other videos that you can check out. And before you leave, if you like the video, please smash the thumbs up button. Until next time, we'll see you guys later.